So we figured out how to rig all the parts. Now we just need to put everything together. But wait, except for the eyes, this character is one single mesh. And things like the body mesh need to be affected by more than one bone. So how do we do that? Well, that actually gets us into a huge topic that is, unfortunately, beyond the scope of this DVD. And that topic is deformations. However, I will show you the barest of bare basics. Blender has a way to dynamically affect meshes, which is called the modifier system. We can access the modifiers for any given object by selecting that object and going to the modifier properties. It looks a lot like the constraint stack, and, well, that's because it is a lot like it. In fact, this is called the modifier stack, and it behaves pretty much identically to the constraint stack. The only difference is that the modifier stack affects meshes and other internal object data, whereas the constraint stack only affects transform matrices. Other than that, they both behave the same way, taking input at the top, modifying that input as it goes down through the stack, and spitting the result out the bottom. I already have two modifiers on this character. We can see what they do by turning them off and on. The first modifier is called a mirror modifier, and it mirrors the mesh across an axis. In this case, I used it so that I could be lazy and only model one half of the character. The next modifier is a subdivision surface modifier. It subdivides the mesh, smoothing it as it goes. This way, I only have to model a low-resolution character. So this is all well and good, but what does this have to do with multiple bones affecting our character mesh? Well, it has everything to do with it. We use a modifier to make an armature modify the locations of mesh vertices. That modifier is called the armature modifier, and it lets you assign certain vertices in the mesh to follow certain bones in an armature. Now, the important thing to realize is that not every bone in the rig should have vertices directly following it. For example, in our finger rig, we want the vertices to bend with the finger digit bones, not scale with the finger control. So whenever I start out rigging a character like this, I always start by laying out the bones that I want to directly affect the mesh. I call these bones deformation bones because they deform the mesh. So let's get started with that. Let's add an armature to the scene, and make it wire X-ray and turn bone axis display on. And the first thing I do before placing deformation bones is to turn on wire display on the mesh. Go to the object properties, and turn on wire display. Note that this is different than wire display from the menu. This overlays wireframe on top of the solid mesh. It also looks kind of incomplete. Not all of the edges are showing. To fix that, go to Display in the end panel, and with the mesh selected, toggle on All Edges. Well, that didn't do much, did it? That's because of a weird behavior in Blender. To make that option actually take effect, you have to enter and exit edit mode on the mesh. Don't ask me why. I think it's pretty darn silly. Okay, there we go. The reason this is important is because the quality of our deformations partly depend on the placement of our bones as compared to the vertices of the mesh. So now we can start adding our deformation bones. Let's start with the body. We're going to use 3 bones, evenly spaced. So move the tip of the default bone up to be the first third, lining it up with an edge loop. Now extrude the second 2 bones from that. And let's align the bones so that the x-axis rotates forward. And of course, let's name them. Now let's add the bones for the arms. Don't forget x-axis mirror to speed things up. And align and name them. and make the arms the children of the topmost body bone. Now for the hands and fingers. Make sure that the fingers are the children of the hand, and align and name them. Note that I'm aligning the hands and fingers differently than the arm, because the most common axis of rotation is different for them. And verify that we got the naming right for mirroring. And finally, let's create the eye bones. Remember, we want them to be at the center of the eye, pointing in the same direction. And make sure they're the children of the top body bone. And there we go. That's all of our deformation bones. Hurrah! But before we start building our rig designs on top of these, I think it's a good idea to make sure that the deformations will work with this layout. Because if, say, you go and build all of our complex rigging on top of this, only to discover later that, say, the body needs more bones for good deformations, or that the finger joint should be placed slightly differently, it would be much more painful to adjust. The first thing to do is add the armature modifier. The easiest way to do this is actually through a shortcut in the parenting menu. Select the mesh, and then the armature, and hit Ctrl-P to parent. There's an item labeled Armature Deform, with several sub-items underneath it. In addition to parenting the mesh to the armature object, these menu items also automatically create an armature modifier on our mesh. The sub-items also do some additional things. I'll only mention two. The first is the Empty Groups item. This will create vertex groups for each of the bones in the armature, but it won't set them up for deformations. I'll explain what vertex groups are in a moment. The second is the Automatic Weights item. This adds vertex groups for each bone, and it also tries to automatically set them up for deformations. In our case, we don't want the computer to do any of that automatic weighting stuff, so select Empty Groups. you'll notice that the wireframe of the mesh suddenly got denser. That's because the armature modifier that was just added comes after the subdivision surface. Blender tries to simplify the mesh view of the subdivision surface modifier when it can, but it can't do that when another modifier comes after it. In any case, we want the armature modifier to come before the subdivision modifier anyway, so that the smoothing gets applied after the deformations, not before. We also want the armature modifier after the mirror modifier, so that it will deform the two sides separately, instead of both sides always doing exactly the same thing in mirror. So move the armature modifier up one item in the stack. And finally, uncheck bone envelopes so that the armature only uses vertex groups for the deformations, and check on volume preservation, which will make our deformations in this case a little bit nicer. Now we need to set up the vertex groups. What are vertex groups? If we go to the mesh properties, we see that there is a vertex groups panel. This is the list of vertex groups on the mesh. You'll notice that these groups have the same names as the bones in our armature. This is not a coincidence. By default, a mesh's vertex group list is empty. But when we parented the mesh to our armature with the empty groups item, it automatically created a vertex group in the mesh for every bone in the armature. I won't go into the details of vertex groups since they're used all over the place in Blender, but in our case they will serve to let us attach vertices to the bones in our armature. Bend the middle body bone in pose mode. Right now, none of the mesh is following the bones of the armature, but we can change that. Go back into edit mode in the mesh, select this edge loop with Alt-right click. Now to make this edge loop follow the middle body bone, we need to assign the vertices to the vertex group with the same name. So let's find the vertex group called body.02 and select it. And now let's click the Assign button. And now exit edit mode. Whoa! Those vertices are now following the middle body bone. If we go back into edit mode, however, the vertices aren't moved anymore. To see the effects of the modifier while we're in edit mode, we need to toggle on a couple of options on the armature modifier. This one, and then this one that appears afterwards. Awesome. Now, the real power of the armature modifier and vertex groups is that a vertex can belong to more than one group. Let's try assigning these vertices to the top body bone, body.03, as well. And now rotate the top bone in pose mode. It now affects the vertices as well, but notice that the middle bone still affects them too. What the armature modifier does is when a vertex belongs to more than one group, it positions it based on the average of where it would be if it belonged to each. But it's not just a straight average, it's based on weights. If we go back into edit mode on the mesh, we can see a panel in the end panel called Vertex Groups. This shows us the vertex groups that the currently selected vertex belongs to. It also shows us the weight that the vertex has for each group. If we tweak the weights, we can change how much each bone affects the vertex. Larger values mean more influence, and lower values mean less influence. And we can copy the displayed weights to all of the currently selected vertices by clicking Copy. So this is how we're going to attach the mesh to the armature. Let's start with the body. To keep us from accidentally selecting vertices from the arms, select both arms using the L key, which selects contiguous mesh pieces, and press H to hide them. Don't worry, we can get them back. They're only hidden, not deleted. Now let's select all of the vertices that we want to only be affected by the top body bone. You'll probably want to go into wireframe mode by hitting Z, and select them using box select by hitting B and left-click dragging. Now assign them to the top body bone vertex group. Hey, look at that! It just jumps right to it. Cool. Now let's do the same for the bottom of the body. In this case, the vertices didn't move because the bone hasn't moved from its default position. Now we need to deal with the middle of the body. This is the tricky part. We need to balance all three of the body vertex groups together so that there is a nice, smooth blend over it. Good weighting is unfortunately beyond the scope of this DVD, but I'll just go ahead and do it, and you can copy if you wish, or practice trying to balance it yourself. There is a certain art to it, so it takes practice anyway. Now we can unhide the arm vertices with Alt-H. Weighting the rest of the mesh is a similar process. So now I'm going to do the rest of the weighting. Just keep in mind that because we have a mirror modifier, we're really only weighting the left side of the body. The mirror modifier automatically mirrors the weights to the other side. Notice that I am often doing the weighting in a posed position, so that I can directly see how the weights are affecting the deformations. And lastly, parent the eyeballs to the eye bones. Whew. Now our character is all set up for deformations.